See? Run it.
That's how it works.
Is our doghouse. And our doghouse has a garage door opener. And basically, we have our circuit set up right here. And so what's going to happen is when our circuit detects a thunderstorm, our doghouse will open, controlled by LabVIEW. And our electronic dog will go into the doghouse. And our thinking behind this was that during like a thunderstorm, usually pets get really scared. And our circuit detects a thunderstorm, it'll open up the garage door to give like our electronic dog a little place to stay during the storm so it doesn't have to be scared. And the computer, it still picks up all like the data, and we can make graphs with the lightning and thunder and just like do stuff with that data while providing the dog a safe, dry place to stay.
But basically the goal is when we turn on this, we're going to run the program. It's going to collect data on our interface. You'll see the waveforms work. This is going to go back and forth. And when this gets hit with lightning, the garage door should open. The car will pass through, hit the back, and it'll touch this bump sensor in the front. And when that happens, the garage door will close behind it. So that's the goal. So there we go. I'm just going to hold the wire back because we don't have a long enough wire. And that's the circuit. Okay, so the point of this project was to get computer input and output. So in our project, the input to the computer, which we kind of did in our last project, but we took it a little further with data. Of course, we have our interface with the graphs, which you see here, and you can see like the lightning strike here, and then the sound threshold for thunder. This stuff all got fed into our Express spreadsheet. That's kind of the new computer input stuff, which is pretty cool. Now, the output that we got to do is, in reaction to the lightning and thunder, we have our circuit put onto this car that we built that we call an electronic dog. And we have it basically making decisions based on the input that it receives from our circuit. So pretty much what our circuit's been able to do is talk to its counterpart, its computer, and its car here. Okay, so here's our LabVIEW code. It's pretty much a, yeah, it's huge. Basically, we use the same lightning detector code as before, but we had to rebundle everything to make it into a certain type of graph that fit for what we wanted to do. So this is just a bunch of bundling and clustering. We had to format it in a way that it could be read into a file and save into data later. So that's the only trick. Down here is the new stuff. So the first cell is just basically saying when the lightning, this says touch sensor, but it's actually hooked up to where our light source is coming in, and it's basically saying when light gets above a certain intensity, which we made this number 100 based on what's coming into the NXT, this will stop and go to the next cell, which will turn the motor on. So this is just reading for light, and once it detects light, it'll go and turn on the garage door and the dog to move forward until it bumps into the back of the house, and then the garage door will close behind it. The bottom part is just it's a while loop telling the sensor, the solar sensor, to go back and forth.
So this is the data that we collected from our circuit, and basically right here, this is the time elapsed in milliseconds. And this is the readings that we got from our light sensor, the lightning. This one is time again, and these match. And this is the data from our audio. And basically what these columns mean is at 51, that's about how much light our solar cell picks up during normal daylight. So we kind of look to see when a lightning struck. So we'll scroll down. So this is milliseconds, that's why it's so long. Okay, we see that the intensity increased to 200 from 51, so that's when the lightning struck, and this is about 11 seconds, and we just added this little marker. And if we go back up, we'll look at where the thunder struck, and right here we're getting like tons of numbers, and that's just kind of like the background noise. But the like threshold for a thunder strike, it's about like over 60, and none of these are over 60. Until we scroll down. Where did the thunder strike? Blah blah blah. At about, this is at 64, so that's the threshold for a thunder strike. About 30 seconds. So then we put in a little equation to like actually use this data for something. And in this cell, we got the time elapsed in between the thunder strike and the lightning strike. And that was about 18 seconds. And then we calculated the distance to the light bolt in miles. And basically we just took the elapsed time times the speed of sound in air, which is like 343 meters per second. And we converted that into miles. And from our data that we collected, that means that this lightning bolt was approximately like 4 point whatever miles away. Done?
So what we learned, one of the first things we learned was working with the NXT. We haven't included that in our project yet, so we kind of fiddled with it before, but this was the first time that we've actually used it in our project. We built a vehicle to carry our circuit around, so we learned how to work motors and the different sensors, which was pretty cool. So just working with LabVIEW on calibrating the motors to work at the same time, and change the power and the direction and everything. So it was kind of cool. And yeah, just using the whole Lego Mindstorm device all together was just a new experience for us. So.
Okay, and then another thing we learned was how to use the LabVIEW code to collect data and store it in Excel. And then from that, we can just like use that data for whatever we want, basically. And then another thing we learned how to solder wires, which was kind of scary. Why did we have to solder wires?
Okay, so we had to solder the wires because one of the things that Dr. Bensky taught us was to not be afraid to tear things apart. So
I was so afraid.
We basically got to cut open the NXT wires and figure out what each one of those lovely rainbow-colored wires do. And so yeah, so we had to solder those wires so that they could be easier to input into our circuit, and yeah, it was kind of cool.
And then what that helped us do, cutting up those wires, is it helped us get rid of lab jack. And we just used those wires instead, because we were attempting just to make our like little robot and circuit as portable as possible. And then along with trying to make our circuit and robot more portable, we replaced our power supplies with a 9-volt battery, and we tapped into the power supply from like the NXT wires. I think it was like green.
Mm-hmm. And
that provided us like 5 volts. And then our 9-volt battery, and that just powers our op amps and everything.
And
did we cover it all?
So our entire circuit has been made wireless from the...
It's not wireless.
Okay, portable, sorry.
It's a little bit.
It counts bubbles.
Our circuit does not count bubbles. Shut up! You're mean. I've had the most awful experience of a lab partner this quarter.
Yeah.
I liked 256 when I didn't have a lab partner better.
Yeah, she was used to getting Fs.
That is not true. I did well. Okay. I just lost my train of thought.
That's nothing new.
Oh, that was me.
Thank you.
Yeah, this is my favorite class.
Yeah, me and Zack both have the same superpower. Everything we touch breaks.
No, but seriously. It's true.
Yeah.
Okay, so...
shut up.
I'm awesome. No, you're not, dude. Don't lie. I'm awesome. I'm driving around in my mom's ride. I'm awesome.